Thank you so much for preparing this meetup for the community. If you want to access this deck, this slide, so you can scan the QR code. And also you can join our community in Discord if you scan the QR code in the upper right corner. So we will talk today about your data. So sometimes we don't know our data. Sometimes we are living in lies. So we need to understand better our data sets. And we need to understand today how we can use the semantic search to create trust in our data sets, in our visual data sets. So before to start, let me introduce myself. My name is Paula Ramos. I am a senior computer vision machine learning advocate lead at Voxel 51. But my past adventures have been full of fun as AI evangelist at Intel, chief engineer at the National Federation of Coffee Growers in Colombia, and also scientific research at the North Carolina State University. So I think that all of us, we are familiar with AI, and we can see how AI is changing the world. And 20 years ago, we didn't have a lot of resources as we have today, but we still got things done. So you can also follow me on LinkedIn. So let's start with the talk. Now imagine that you have, as an engineers or developers or data scientists, you have a model phase in production. And this car is not able to identify a huge white truck crossing a highway. So, and this is a real scenario that happened in 2016 with a huge company. And the model was failing to detect system failure. And why that happened? It may be because the model was overfitting, or the model was missing the edge cases. So these critical scenarios that maybe we don't have the representation of those critical scenarios in the training data set. And the question mark is here, how we can fix this. So for years, we have been moving this AI stuff in the model-centric approach, where basically we have a data collection, we train our model, we deploy the model, but question mark is we didn't have these critical scenarios, and finally the system crashed. So nowadays, we need to move forward for the data-centric approach, where basically we have the same pipeline, but we are fixing the data set to identify those critical scenarios. And finally, we could have a safe deployment. So we will talk about this and navigate this behavior with this data set that is called VDD100K. It's a large-scale driving video database where we have 100K images. But these 100K images doesn't mean 100K useful samples. So imagine that we have, the model is failing because a traffic light is occluded. We need to understand where the model is failing and how we can fix that, increasing the dataset quality. So when we have this amount of data in our datasets, we can see that maybe the model is not performing well. It's not because it's dumb, it's because it's training on lies. And the most of these lies are hidden in your data set. So with noisy data, redundant data gaps, and for sure the model could be overfitting because maybe you are not selecting the proper samples to train your model. This is a massive explosion that the consequence at the end is a bad model. And I think that you are feeling that, I was feeling that. Imagine that this is an engineer just putting the model the first time to see the raining day in production. So I'm sitting in the back part of the car just trying to fix that my model is failing. It's a little bit fun, yes, but it's happening, it's real. So how we can fix that? How we can find those critical edge cases? How we can find those cases to retrain or fine-tune our models? So the first thing that are in our minds, or we could have this in our minds for a while, is maybe make Control F. Control F, try to understand the directory tree, try to bring these timestamps with our samples, the labels, or the file names, or the patterns that we have in the directory structure. So, but maybe we need to make a transition. This is not enough because we are trying to understand with these tables, JSON files, where the mislabel is. And imagine making this by hand. It's really frustrated. And we need to make this transition. We need to make this transition between, these patterns that we are talking about. We need to move this beyond the file names, the labels, this manual spot checking. And we need to make this transition to enhance visual understanding. So we need to use embedding-based representation and similarity search. With these techniques, we will improve the data curation, we will reduce the noise in our data, we will enhance dataset quality, and at the end, just fixing this, we will have a better AI models. So, and let's see how this could work. Imagine that we could inspect our dataset interactively, not with the file name, but with visual meaning. So we have the embedding models turn images into high dimensionality vectors. And those vectors, we can find similarity indexes that can help us to find visually and semantically those images, those similar samples. So we can group, we can search, we can see the patterns emerge. So for example, in this case, we are trying to find a school bus, and we are just putting this prompt and say, okay, show me the school bus here, and let's see what is going on. Maybe we have school buses, or maybe we have some data set that the model is detecting this as a school bus, but this is not a school bus in reality. So maybe it's a taxi, or maybe it's a white truck. So we need to fix those problems. But inspecting the data set in this way will help us to improve the data set quality. So how this is working? So I know that the majority of you are familiar with vector search, but maybe not. Let me just make a little introduction about what vector search means. So basically, in this latent space, you are putting together two kinds of embeddings, so for text and for images. So basically putting together a dog playing on the beach at sunset with the image that is representing a dog playing on the beach at sunset. And that representation is giving you a number. So finally, when we want to search that specific image that has not only the information from the image, but also the information from the prompt, we will see that latent representation, and we can find the image properly. So under the hood, embeddings are used to compare the semantic meaning of each image, allowing you to identify relevant samples without requiring any labels. And this is really important because right now we need to have time for improving the models in different ways. So, but using embeddings will help us to improve and spend less time on this analysis. Okay, so what we can do with these embeddings, when we have these embeddings, when we have the clusters, depend for sure of the model that we are using, we can cluster in this visual space. So in this specific case for autonomous vehicles with this BDD 100K data set, we can cluster rainy night images, we can cluster images with bikes or ambiguous stop signals or foggy images. So imagine that after I can cluster and identify that, I can fix the problem of my model. So this is remarkable for data scientists and for engineers working in this field. So let me jump in the demo. So maybe you are familiar with FiftyOne, maybe not. So I have some videos prepared here, but I will jump to the, give me a second, I will jump to the real demo here. So I have here the BDD 100K. So this is FiftyOne. So basically FiftyOne is an SDK and also it's an application. So programmatically in the SDK, you will say, what do you want to do with your data set? We are loading data set in this case, and we can see all the data set with the metadata. So basically we have here the metadata of this. So we have weather of this data set. We can just, for example, put foggy images here. And we can filter and curate the data with this metadata. Okay, I have scenes. I can also see what kind of scenes I have. I need a highway, and I can also see the scenes that I have in the app. So the time of day, so maybe I want to see night, for example. And we can see, weather, scene, and what is matching with my selections here. This is a great way to understand your data. But a part of that, let me just clean these filters here. We can explore our data set with embeddings, as I mentioned before. We have this panel that is called Embeddings. It's an interactive plot where basically you can play with the dimensionality reduction that we have for the embeddings. So remember, the embeddings are high dimensionality vectors, and here we have a dimensionality reduction. We are using UMAP, but you can also use principal component analysis, and you can use multiple methods. In this case, for calculating these embeddings, we use CLIP. And we can color this with different kind of metadata. Let's do that with time of day label. That is basically night or day. And I can select part of this cluster here. And I can see this is the cluster that is related with the daytime. If I go here, this is the cluster that is related with the night time. But I can see some outliners in my embedding, so I can select here and see what is going on with this with information. I have the dashboard in the middle of this image. So this helped me as well to identify some problematic images, or maybe I also need to understand quality of my images. So this is another thing that also you can use with FiftyOne. Let me just close this panel, and I will jump to another panel that we have, that is data quality. So where basically, for example, we can take a look of the blurriness and see the blurriness in our data set. So we have a template here where you can select the threshold of this index. Okay, I want to see this threshold on my blurriness in between 1.87 and I think it's 150. So let's see this one. This is really blurry. And maybe this kind of information, I need to include this kind of information in my training process, because I'm taking images from my vehicle, so I need to have movement. So I need to include this as a critical use case. Okay, so let's move forward. And let me show you something here that is really cool. Let me close this panel. And I think that this, yes. So now what is going on? So we can go here and sort by text similarity. That means that we can use semantic search and find something that is meaningful here. For example, people crossing a street. So I can find those images. It will take some time. In between that, let me just jump again to my example. So here, for example, you have documentation of FiftyOne. So, and you can navigate different kind of vector search engines. So we have support for Quadrant, Redis, Pinecone, MongoDB, Elasticsearch, and also we have Databricks as well. And also we have a lot of examples that you can follow up. So let's see what happened with the example. This is still running, but here, yes, this is coming. And we can see people crossing the street. This is saving a lot of time. You can find those critical cases and include this data in our training data set. So let me come back to the presentation. Okay, so now you are familiar with FiftyOne. So you know what how FiftyOne is and what FiftyOne is. So it's the question mark. So FiftyOne is the only open source data-centric AI solution where you can curate, visualize, analyze data sets. You can streamline annotation workflows. You can find and fix labeling mistakes. You can identify and correct model failures. And for sure, something that is really important, FiftyOne makes visual AI a reality. And visual AI means everything related with visual, images, video, 3D point clouds. And we are supporting different kind of computer vision tasks, but also we support different kind of formats. So we support classification, detection, instant segmentation, semantic segmentation, polygons, polylines. You can see, what kind of tasks we support. And it's super flexible. What that means that FiftyOne can help you to curate your data, understand your data, also evaluate your models and make a comparison with different models that you have. But if you have your pipeline in the MLOps pipeline, we can also integrate with different kind of tasks for model training, for augmentations, for testing and validation. And we can cover this from data to production. We can also monitor and maintain the model, digesting information directly in FiftyOne and making the analysis there. We have two options in FiftyOne. We have the open source solution and we have also the enterprise product. So basically it depends of what you need. So right now, if you think about the open source solution, it's because you are a single user focus, you have a local data usage and you are using this for individual experimentation. But if you need the enterprise, if you have a multi-user collaboration, you have billions of samples, and also you need a string connection with the MLOps orchestration. So you can scan these QR codes also if you access these slides, so you can try in browser, book a demo, or read the documentation in the repository that we have. For this specific example that we are talking about, finding those problems in the data set, we have examples from the open source solution, so also you can scan this QR code. We have the semantic cell recipe that is working with Databricks, and also a notebook that you can follow. So basically what this means, so that you need to connect with the data, with the source. In this case, is the Databricks data lake. You need to load the data set into FiftyOne. You need to compute the embeddings vectors, and then you need to generate the mosaic similarity index if you are using Databricks. If you are using another kind of vector search engine, we have also the support for those indexes. And then you can curate your data by similarity. So this is the open source solution. So in the enterprise solution is called Data Lens. Also, you can scan this QR code and see what Data Lens is. But basically, we are making the same. You can integrate your data with different sources. You can quickly find information from these large data sets. You can preview your data in FiftyOne, and then you can import this data. But imagine that you have billions of samples that you need to curate with similarity. This is the solution. So high-performing models don't need more data. This is something that is clear. We need to improve the dataset quality. So your data is lying, and find the truth with semantic search is the solution. So, and I want to bring this meme about Neo in Matrix. When he is connected to a machine, just try to learn Kung Fu. So we are feeling as Neo at that moment, after embedding your data set and seeing it clarity for the first time. So we can learn too much if we understand the embeddings and we use the correct models from the embeddings. So we can search visually and not manually. This is another thing. We can fix problems before it hit in production. And we can bring this to our MLOps pipeline. No matter if it's open source or enterprise, we can bring this for our MLOps pipeline. So this is a video using Databricks. I will play this and I hope that you can listen to.
Start on the Databricks side. Right now we're looking at a Databricks workspace, and within that workspace we've built a catalog of data that contains samples, metadata, and labels. We can query and filter on this data. We also have an embeddings database which has embeddings for all samples. Take a look at this big array of embeddings data that we'll use to compute image similarity or do contextual text search. We interact with this data in Databricks. This is a notebook very similar to other Python notebooks, but it runs in the context of Databricks and it has access to those data catalogs. Here we're going to associate one of our tables with Spark to read from that. We can see the schema of the table and printing out one row to see what that data looks like. We're going to filter based on samples which contain a pedestrian detection. We're able to do that quickly with Spark and then print out one of those samples as a reference and display that single sample. We can view that image and do something with that. Obviously, this becomes very challenging with visual data and many samples at a time. You want to do complex querying and filtering. You want to validate that your labels are positioned correctly and things like that. So for that, we'll move over to FiftyOne. We can use the data lens to explore samples stored in Databricks. The data lens is a framework built in FiftyOne that allows us to connect to any external data source. Let's query that data. We're going to leverage the embeddings and Databricks vector search capabilities to do a contextual text search for person, crossing, street. Rather than explicit filtering, this will give us data to seed the rest of our data set. We were able to query Databricks and we got back these samples. We can see them visually, the labels that are drawn on top of them, bounding boxes. We'll choose a small sample size, a seeding set. We'll add these to a new data set and import this directly into FiftyOne. Now we can open those up and see our imported samples here. We have a small subset of samples in FiftyOne. Let's refine that data to find the most beneficial examples to our model. We'll select a few images where pedestrians are actively in the crosswalk and use data lens again, this time finding similar images. This should give us a data set more representative of the type of data that we're looking for. Now let's import those and make this a more realistic data set. Once the import is completed, we can add this to our training data set and improve the performance of our model. Start on the Databricks side.
Okay, so I think that with that, so we have two different approaches. So we were talking about the open source solution and also the enterprise product. So you need to make your choice. You have the resources in this talk. You can test with open source and see if you need, depending on your needs, the enterprise solution. So, but basically coming back to this first idea that we need to move forward with the data-centric AI approach. So with the data-centric AI approach, we can reduce bias and errors in our data sets. We can increase and refocus in the dataset quality, and we can also create like a cost-efficient optimization. So we don't need to train models with a lot of data and having a bad performance. When I say performance, I'm also thinking about runtime, and if we have high computational costs and we increase the model complexity, we will need more infrastructure. And for sure, if we move forward with this model-centric approach, we could have these persistent bias issues. So choose data quality for efficient AI is my choice. So if that is not clear, so this is something fun as well. I would prefer to go to Disneyland than go to the Lord of the Rings. So, and this is a debate for the next steps, because sometimes we need also to change our mind in moving forward for the data-centric AI approach. Just wrapping up, we have unified visual AI benefits with FiftyOne. So what basically we have is time efficient, because we have a streamless process to save value time. We can have cost reduction. We can improve the accuracy of our models, and we can also enhance the answer of our actionable insights with our models. Finally, we have a coherent visual AI platform that is called FiftyOne, and is made. This platform is made by Voxel FiftyOne. And Voxel FiftyOne is the company that is sponsored this meetup, but we also are the lead maintainers of the open source FiftyOne toolset, and we are making visual AI a reality. So if you want to see and learn more about Voxel FiftyOne, so you can take a look in our documentation as well. Or what is the next step, so you can join our community, attend our events, book a demo, and pip install FiftyOne, as simple as pip install FiftyOne.